everyone, this is Mrs. Moriarty, and I'm here to discuss with us topic 4.4, which is going to be all about Earth's atmosphere layers. So, first looking at what is Earth's atmosphere specifically composed of? Well, thinking back to Unit 1, especially when we discussed the nitrogen cycle, we said that a lot of our atmosphere is actually comprised of nitrogen gas, just about 78% or so, with about 21% being oxygen, and we can see at least a few others, trace gases like carbon dioxide, argon, water vapor, kind of make up the remaining parts of Earth's atmosphere in terms of components. Now, what are the layers of Earth's atmosphere? Remember, we investigated some of those today in class with our virtual ballooning assignment. So here, the exosphere, that would be the absolute most outermost layer where the atmosphere merges with space. Followed by the thermosphere. This is where we actually see the hottest temperatures amongst each of the atmosphere layers. This is where a lot of harmful, maybe X-rays or UV radiation is then charged as gas molecules glow under intense solar radiation absorption. So this can produce things like the northern lights. Next would be the mesosphere, right? Meso meaning middle. It's about 60 to 80 or so kilometers in terms of altitude, and it is less dense in terms of molecules. Followed by the stratosphere. Think of like S, stratosphere, S for second layer of Earth's layers of atmosphere. It's about 16 or so to 60 kilometers in length. It's less dense to the less pressure from any layers above it. However, it is the area in where we see majority of the ozone, or O3. So the stratosphere is actually where we see the ozone layer. So here in the stratosphere, its main job is to absorb harmful UVB and UVC rays, which can wind up mutating the DNA of organisms found on Earth. And then lastly would be the troposphere. That would be the one closest to Earth's surface. This is where weather is going to occur, and it is most dense due to the pressure of all of the other layers found above it. Now, most of Earth's atmospheric gases are actually found in the troposphere, hence why a lot of weather takes place here. Ozone can also be found in the troposphere. However, when ozone is found in the troposphere, it is considered harmful, especially if we were to breathe it in. It is actually a respiratory irritant and has the potential to damage plant stomatas and form what's known as photochemical smog. We will talk more about ground level or tropospheric ozone when we discuss it in Unit 7, but for right now, what I'd like us to know is ozone found in the stratosphere is good ozone, while ozone found in the troposphere is bad ozone. So here are our layers of the atmosphere. Remember, troposphere closest to Earth's surface, where weather occurs, where most molecules will be found, followed by the stratosphere, which is where our ozone layer is, mesosphere, thermosphere, and exosphere. Remember, from our virtual ballooning assignment, we also learned that the boundary between each of those layers is also known as a pause. So in between the troposphere and stratosphere is the tropopause. In between the stratosphere and mesosphere is the stratopause. So how does temperature change as you increase in altitude? Well, we discovered today with our virtual ballooning that depending upon where you might be is going to tell us a lot about the temperature change or gradient in that layer. The thermosphere temperature increases due to the absorption of very highly energetic solar radiation. It is actually the hottest place on Earth, but the mesosphere's temperature actually decreases because density decreases, a lot fewer molecules in order to absorb that solar radiation. The stratosphere, we know as you increase in altitude, also increases in temperature, and this is because of all of the ozone that's found there is absorbing a lot of that harmful UV rays. Then our troposphere is going to decrease as you increase in altitude, and that's because as air gets further right from warmth of the Earth's surface is why it decreases in temperature. But what about pressure change as you increase in altitude? Pressure is going to decrease as you increase in altitude in each layer of Earth's atmosphere, and this pressure change with altitude is due to the decreasing density of air molecules. So remember, at the troposphere is where we see the most air molecules, but as you increase in layers, you see less and less of those molecules. So in the troposphere specifically, pressure decreases with that increasing altitude. Pressure at the surface is going to be highest, so as it decreases as you move upward. So here is our practice FRQ for 4.4 using the graph to the right here. Identify the only layer where water molecules would be found in liquid form. And B, based on the graph, describe the changes in the pressure as an object moves up through the layers of the atmosphere. Take a moment, answer this in your practice FRQ journal and on the Edpuzzle. Okay, looking at the first question there, in which layer would you find water molecules in its liquid form? That would be the troposphere, because remember, that's the layer closest to Earth's surface, where the most molecules would be found and where weather is going to occur. Remember, in the second one, describing pressure, pressure is highest in the troposphere and decreases significantly as you move up the atmosphere, right, due to less and less density of molecules. All right, everyone, that's it for our video on 4.4. If you have any questions, please leave that at the end of the video.